Hi guys, welcome back to the channel. So today we are going to be solving today's LeetCode question, which is add one row to a tree. So we are given a binary tree and then we are given two integers. One is value and then the other is depth. We need to add the row of nodes with the value val at a given depth. Suppose let's say this is the given example where we are given root of a binary tree and then we are given value which whose nodes is going to have this particular value, and then we are going to add this particular value nodes at the depth of 2. That means this is going to be depth of 1 and then this is going to be depth of 2. So as this is depth of 2, we are going to add the nodes which are present here, and then let's say here we have, for this particular node we have left and then right, and then this is depth 2. Now we have left and then right. So for this we are going to insert new node, and then whatever the left of this particular node which is present, we are going to assign this particular left node to this particular new node which is created. And then whenever we have right node, we are going to have new node, and then whatever the right node which is present for this particular node, we are going to assign it to the right of this particular new node, and then at last we are going to return this particular tree node. So that is how we are going to solve. Suppose let's say this is a particular example where we need to add the values of 1 and then 1 at the depth of 2. So suppose let's say depth equal to 2. Now we'll do the traversal of DFS. Suppose let's say here I am present with the value of 4 and then depth of 2 and then value is going to be 1. Why? Because we are going to add this particular new node with the value of 1. Now what I'll do is I'll decrease the depth. So at this particular point we are going to decrease the depth. That means it is going to be 1. Now we can say that this particular depth is what we want. That means the next node which is present is going to be my depth. Suppose this is 1 and then this is going to be 2. So what we want is depth 2. So we had decreased to 1. Now the next level which is going to occur is going to be our depth. That means we are going to have this particular left as well as this particular right. So for this we are going to add new nodes to this particular root, and then we are going to assign left to here and then right to here. So that means the pseudocode is going to be like this. Suppose let's say I got the root. So now we are going to create new nodes, which is going to be node 1. Node 1 is going to have new node with the value of val. So we are going to construct new node with the value of val, and then we are going to construct one more node which is going to be node 2, which is going to be our right node for the particular value. So these two nodes we had constructed. After constructing these two nodes, we are going to assign left root left to here in this particular node 1, and then root right to this particular node. So we are going to say that node 1 left is going to be root left, and then node 2 right is going to be root right. So this is going to be my answer. And then let's say after doing this, there is going to be connection between this particular 4 and then 2, and then this particular 4 to 6. Now we need to take out this particular pointer which is pointing to root left to here, and then we need to mark this to here. That means we are going to say root left is going to be node 1 and then root right is going to be node 2. So that's what we are going to do. So let's say for this we are going to say that root left is going to be node 1 and then root right is going to be node 2. So and then at last we are going to return the answer. Suppose let's say it is not the depth we wanted, then we are going to traverse the left and then right, and then that particular recursion is going to do give us the solution, and then we are going to return the answer. So if we come to the time and space complexity, it is going to be big of n. Why? Because we are traversing whole tree, and then if we come to the space complexity, it is going to be big of n. So let us go through the code once. So what we are going to do is, suppose let's say it is of depth equal to 1. That means we need to create this particular new node at this particular level. So we are going to create this particular new node, and then we are going to say that root left is going to be this particular root, and then we are going to return that. Suppose let's say this is not depth equal to 1. That means we are going to do this particular construct where root and then value and then depth, and then let's say if the root doesn't exist, then we are going to return null itself. And then let's say we'll decrement this particular depth, and then if the depth equal to 1, then we are going to construct new node 1, and then this is going to be new node and then new node 1, and then new node left is going to be root left, and then root left is going to be new node, and then or we are going to build one more node which is going to be new node 1, which is going to take the value, and then this right is going to be root right, and then we are going to assign root right to here. The same thing which we had done here, like we are going to create two nodes and then assign left to this particular root left, and then we are going to assign new node right to this particular right node, and then we are going to say that this root left is going to be this particular new node, and then root right node is going to be this particular new node. And then after that we are going to say that we are going root left or using this particular value with the depth of depth, and then at last we are going to return the answer. If the depth is not equal to 1, then we are going to do this particular operation. If it is equal to 1, then we are going to do the construction of new nodes, and then we are going to return the answer. Yeah, that's all for this video. Thanks for watching.